All right, so welcome everyone to the STORK Fall Series. We're going to have another fall series on November 2nd, so be on the lookout for that. But today we have Dr. Eimear Dolan from Sao Paulo, University of Sao Paulo, via Ireland, probably via many other places, to share with us systematic reviews and meta-analyses. So take it away.
Thank you very much, Vanessa. Thanks a million for that. I'm really pleased to be here today. This is a subject I feel quite passionately about. I really enjoyed the topic and I'm really pleased to have the opportunity to talk here today. I love the work of the group. I think it's fantastic. I think it's exactly what our field needs. So to have the opportunity to present here is really great. So today I'm basically going to talk through systematic reviews and meta-analyses, and I'm not really entirely sure how I personally got started with this. It was a few years ago. I was working in Robert Gordon University in Scotland, and they gave us, there was an opportunity to do, I think it was a 2-day introductory course on systematic reviews. And I thought, yep, that sounds interesting, I'll do that. After I did the course, I thought, I'm going to have a go at one of them. I'm going to see how I get on. And I did one, in hindsight, extremely inefficiently. But I enjoyed the experience and decided to have a go at another one. And then it just kind of snowballed. Some colleagues were like, oh, I see you've done 1 or 2 of these. Do you fancy getting involved in this one? And I suppose it just kind of took off from there to the point where I now seem to be spending the vast majority of my time working on this type of paper. Every single project that I've worked on, I think 7 or 8 published and another 6 or 7 on the go, obviously mainly collaborating, I'm not leading all of them. Every single time I've worked on one of these, I've learned something that I've kind of tried to take to the next one. And on the one hand, that makes me really happy, that I feel like I'm moving forward, that I'm developing, that I'm progressing on it. On the other hand, it freaks me out a little bit because I kind of think, oh God, what am I going to learn on the next one that I should be doing on this one? So I think what I'm basically going to try to do here today is to talk through the procedure and to talk through the guidelines, the recommendations for developing the protocol and running one of these types of studies. I'm going to try to share some tips and tricks to hopefully help, if you're thinking of doing this, maybe help you avoid some of the mistakes that I have previously made. However, as I said, it's such a learning, iterative process. I'd also be really keen to hear your thoughts on anything. If you have anything to add, completely disagree with something I said, or if I've missed something or misinterpreted something, please feel very free to hopefully we'll have time at the end to have a bit of a chat around it. So essentially what I'm going to do now over the next 40 minutes or so is I'm going to talk through a series of sequential steps that I would really recommend that you all consider before actually starting on your analysis. What I'm going to focus on today is the development of the protocol and all of the things that you should consider when you're developing your protocol. Once you've done all of this, the actual doing of the analysis should be pretty easy because you should have tested out every single stage. So the actual process of doing it should get pretty easy if you do the initial bit right. But that initial bit can be tricky. There's a lot to consider. Luckily enough, there's also a lot of guidelines out there that help to guide the process. So to write this talk, I'm going to point you in the direction of some guidelines that you might find useful, some resources that you might find useful. In the time that we have today, obviously, I'm not going to dig deep into any of these topics. We need dedicated talks on each of these 7 steps that I'm going to discuss to really get into the details. So my aim is more to just give you a bit of an overview, an outline of things that you should consider that you can then hopefully take to your own, and also to point you in the direction of some resources that may hopefully be useful when you're developing your own systematic review meta-analysis protocols. Throughout it, I will focus, a lot of what I'm doing here relies quite heavily on the PRISMA guidelines, which is the preferred reporting items for systematic reviews and meta-analyses. Up till recently, we were all using the 2009 guidelines, and there's a checklist there that kind of talks you through the different things that you should consider. Luckily enough, just a few weeks ago, the 2020 guidelines were released. They're still as a preprint at the moment, but they're freely available online. So I've included links to some useful resources like this throughout. As I say, I really would recommend there is a lot to consider when you're thinking about doing a protocol systematic review and meta-analysis, but there's also a lot of really useful resources available that can guide you through this process. So if you decide that this is something that you want to do, I really do recommend that you have a look at them. The kind of the more subjective advice that I give, take from it what you will, agree or disagree as you will, but the kind of the published guidelines I really would recommend having a look and taking them into account. So essentially what I'm going to talk about over the next 40 minutes or so, initially deciding whether or not it's actually something that you want to do and whether it's appropriate for your research question. We're going to talk about defining your question, your eligibility criteria, how to go about actually finding, sourcing your material in the first place, extracting and coding the data that you're going to use, data synthesis, how you're going to combine that data that you're in reports, the data that you're actually going to end up with, how to ascertain confidence in those estimates or those outcomes that you end up with, and I'll finish off with just mentioning a little bit about protocol registration and publication. So that's basically what I'm going to talk about in the next while. Just to make sure that we're all on the same page, I'd like to start out with some simple definitions. I think it's always useful just in case we end up talking about different things. This is what I'm trying to talk about. A lot of people, the first question is like, what's the difference between a narrative review, excuse me, and a systematic review? Well, essentially, a narrative review is going to be a qualitative summary of evidence on a topic. It's generally going to use quite informal or subjective methods to collect and interpret studies, and it's typically going to be conducted by an expert in that area. For example, somebody has a whole series of studies in an area, they might decide to bring them all together to discuss the overall topic area. So they can be a really fantastic resource to kind of give you an idea of what's going on overall in your research area. On the other hand, a systematic review addresses a very clearly defined question through the objective synthesis of pre-selected studies that address one specific study and this question, and studies that are selected according to predetermined eligibility criteria. When we talk about meta-analysis, we're basically just talking about the statistical combination of available data into a common outcome. So basically, you can have a systematic review without meta-analysis, depending on your data. The meta-analysis bit is just when you add the statistics to your project. So to me, a systematic review has a lot more in common with an original study than it does with a narrative review, despite the fact that they're both called reviews. Because essentially, you come up with a question, you design a methodology to allow you, hopefully, to answer that question. You apply your methodology, you analyze your results, and you report your results. It should be a very objective process. Your opinion in terms of what that answer means, whether you agree or disagree with it, you're welcome to your opinion, but the answer is the answer. And so in that way, I think it's more like an original study than, say, a narrative review, which is much more subjective. There's much more space. Obviously, you want to be as balanced and as possible in your narrative reviews too, but this is more of a very objective procedural process. So that's basically what we're talking about. I'm sure quite a lot of you have probably seen this hierarchy of evidence before, where we talk about ranking different study designs in terms of their overall strength of evidence that they provide. And something that draws a lot of people to systematic reviews and meta-analyses is the fact that they're right up there at the top of the pyramid. They're seen as being kind of the strongest available evidence. I think all things being equal, I can see some merit to this kind of hierarchical approach. However, I think that this may potentially be a more better way to represent strength of evidence in terms of any good study that uses an appropriate design to address a relevant question is strong evidence, and anything that doesn't is more down towards the bottom in terms of weak evidence. So in terms of that, I think automatically assuming that something is high quality just because it has systematic review and meta-analysis in the title, that's kind of shaky ground. You need to be careful there, because not all reviews are created equal. We have some fantastic reviews that provide really useful information to the field, that really push the knowledge in the field forward, and we have others that are, to be honest, just a bit useless. And I think it's really important that we consider the difference between them both. Obviously, I created this very ridiculous looking little triangle by myself, but I actually saw somebody on Twitter presenting this hierarchy of evidence in this way, and I can't remember who, so sorry I couldn't attribute that kind of description to anybody, but there we have it. Anyway, so if you're thinking about doing a systematic review meta-analysis, some reasons that you might want to consider this is a way to help to achieve consensus on the state of knowledge in a particular research area. And this is particularly important if disparate results have been published. I think if you're working in an area that has, say, quite a large quantity of research available, but where you find it very easy to cherry pick a study that will support whatever point of view you wake up and decide to support on that particular day, that's potentially an area that could be quite useful to bring that together to try to get to a bit of a consensus on what the data is actually telling us. These studies can be very, very useful to identify problems in primary research that may be systemic issues that we need to consider rectifying as we move forward. That can be very important in identifying priority areas that, again, we might want to consider moving forward. And those are very useful outcomes. And it can allow us to address questions that maybe can't be answered by individual studies. And I think this is particularly relevant in sport and exercise science because it's the nature of the beast. We tend to study phenomena that are likely to have very small effects, meaning really we need massive numbers. However, our research is pretty difficult when we're putting people through training programs, exhaustive exercise tests, maybe taking blood samples, muscle biopsies. It's very difficult sometimes to get the resources together to do the size of study that we theoretically need. And one potential approach to overcoming this problem, or to at least contributing towards overcoming this problem, is to combine those studies, similar studies, into a meta-analysis to try to get a bit more of a consensus than maybe any one individual study is able to give. On the other hand, there's some reasons not to do a systematic review. I think sometimes there's a bit of a thing of like, well, I need a publication, and systematic reviews are high quality in the hierarchy of evidence. Look, it's probably where a lot of us start with it, but I think if that's your only reason, rethink. There needs to be more than that. And as I kind of just said, just because systematic review doesn't necessarily mean that it's a high quality piece of work or a strong piece of evidence. It's very much going to be determined, the quality of what comes out of your review is so going to be determined by the quality of what you put into it in the first place. And so I think for sure you need more than that. You also need more than, because it hasn't been done before. This is something that I see more and more. It's like, oh, we've got a research area, we've evaluated from this area, but we haven't looked at it this way, so I'm going to do this review. Again, if that's your only reason, just take a moment to stop and think, is there any possibility that the reason it hasn't been done before is maybe because it's just not very interesting or useful? Now, obviously, what makes a research question meaningful or useful is very subjective and very context dependent. However, what I'm trying to say here is don't stop with that. Don't let that be your only reason. Carry it forward and try to think, do I actually need, will my review really advance knowledge in this research area or not? Being new is not enough, I think, in my opinion. Our questions don't just need to be new, they need to be meaningful. They need to contribute something, however small. We don't have to change the world with every article, but we need to make some kind of contribution. So I think first and foremost, before you embark on this process, which is time consuming, can be tedious. Personally, I love it. I enjoy the process a lot. I find it very satisfying to kind of have a plan and systematically see it through. However, it is time consuming, it is a lot of work, and it is quite difficult. So before you embark on it, have a think about whether it's definitely something that you want to do. So, assuming you've made the decision, you haven't logged out and decided, right, I'm off. Assuming you've made the decision that you would like to go ahead and do it, the first thing you need to do is to define your research question. I think it's important here to differentiate between a research topic and a research question. A research topic can be quite broad. Let's just say, for example, the influence of vitamin D on bone health. Now, that can be tackled from an awful lot of different aspects. For example, we've got cell studies, we've got animal models, we've got cross-sectional studies, observational data looking at people's typical intake or baseline status in comparison to like bone density or whatever, and we've got control trials that supplement. So you can write a narrative review where you kind of bring in all of those aspects, but good luck trying to combine everything like that into a single systematic review. What you really need to do is to define a specific question within that research topic that you can feasibly answer. So just as an example, I just made this up obviously, but an example of a question that you might address within that is, does supplemental vitamin D influence bone mineral density in postmenopausal women with vertebral fracture? That's a focus question that you can actually get your teeth into and actually figure out an answer to. When you're thinking about your question, there's a number of tools and frameworks that will allow you to kind of, I suppose, focus your mind on the places that are most important. And the PICO approach is a very useful one, particularly in studies that use some kind of intervention, which a lot of us work with. So when I'm talking about PICO, it's looking at the population, the intervention, the comparator, and the outcome. So if you consider each of these aspects within your question, you can start to kind of dig into a more specific focus question. So just as an example, in resistance-trained young men, that's going to be our population. Does supplemental protein or intervention enhance lean mass gains, our outcome, in comparison to resistance training alone? That's how we're going to decide whether this works or not. So that's just an example. Again, these are just things that are true together. You can think about how to apply to your own way. PICO is very useful and it's very common, but be aware that there are other ones, other kind of acronyms and frameworks that might be more suited to other research designs. For example, there's also also pronounced PICO, but PICO, where the CO is context, which might be more useful for an observational study. There's the SPIDER framework, the SPICE framework. Don't ask me to rhyme off what all of those abbreviations stand for because I forget. But basically what I'm trying to say here is I'm going to try to give you the heads up on some potential frameworks and guidelines that you can use to guide your own study. However, there is a lot available, so it's good to search around and make sure that the guideline that you're following is most appropriate for your research design and research question. So you've got a question. The next thing that you need to do is to consider what kind of studies you need to select in order to be able to answer that question. So what are you going to let in? What are you going to get let out? And so you're basically defining the parameters within which you're going to run your review. You can use the same framework. I think it's a very useful way, again, just to focus the mind, to keep you focused on what you need to consider. You'll notice here I've added an S. I'm pointing at my screen. I realize you can't see that, but I've added an S here, which stands for study design. So here we've got the PICO approach. So first and foremost, think about your population. Who do you want to work with here? Age, sex, health status, or training status. Always keep in mind that the generalizability of your results are very dependent on who you're studying. So if, for example, you want to write a review that can be applied in the context of elite sport or give advice to elite sport, don't choose studies that are based on sedentary populations. They might have completely different responses. So think carefully about the population that you want to investigate, and that's going to be interesting for you. Look at your intervention. Again, this comes very much down to what exactly it is that you're studying. For example, if it's a sports supplement, you might want to look at the length of the supplementation period, the doses that are given, the types, are they in gastro-resistant capsules or not? There's a lot of factors to consider there. If you're looking at, say, an exercise intervention, maybe use something like the fitter principle to hammer down to what frequency you're going to allow in, what duration. If you just let in all studies, you risk really muddying the water. Like, say, for example, you're looking at response to a training intervention. Well, we all know that there needs to be some time there for training to take effect and for the body to adapt. The length of that time will depend on how plastic the tissue or the outcome that you're trying to impact. But if you start letting in, say, training studies are 2 weeks or a month in time, but then you measure, say, bone mineral density that we already know needs substantially more time to adapt, you're going to say, all right, it doesn't work, but maybe it didn't work because you didn't have time. So you really need to think about the parameters within which what you are investigating may or may not work, and then define your inclusion-exclusion criteria for your study according to those. Next, you're going to think about your comparator. Ultimately, most studies in general come down to a comparison between measurement A and measurement B, and whether or not there's a difference. And a very important thing to consider here is, what are you going to compare to? For example, are you going to only compare to a randomized control group, a placebo condition? Are you going to consider just pre to post change? Are you going to look at repeated measures within a crossover design? Are you going to look at independent groups? Again, there's all these things to consider, and they're all going to depend on your specific research question and what's most appropriate for it. So there's no clear-cut answers here. I'm just trying to highlight things that you might want to consider. In terms of your outcomes, this is essentially what you're going to measure. I think in science in general, we can't measure phenomena. We can just measure surrogates that give us some indication. So for example, I personally work a lot with bone health, but there's no way to measure bone health. So I measure surrogates. I look at bone mineral density by DEXA or microarchitecture, or I take blood samples and look at biomarkers that are indicative of particular processes, and they can all give me an idea of what I'm ultimately want to know, but none of them are actually the perfect measure. So it's important to think, like, what are you going to use to answer your question, and what is the most appropriate measure? So use the example of that resistance training question example. Maybe you're going to look at muscle mass, maybe you're going to use DEXA, maybe you're going to look at biochemical indicators of muscle turnover, the rates of protein synthesis versus degradation. You could look at muscle function versus various functional capacity tests, strength using 1 rep max to 10 rep max, endurance, etc. You have so many options there that you need to hammer down what is most appropriate for your question. I think it's really important here that you prioritize your outcomes. It is very likely that you will have more than one outcome, especially in sports science. In general, we tend to have multiple outcomes and multiple ways of looking at the same thing. So that's fine, but be careful to prioritize your outcome and to clearly define what's your primary outcome and what maybe is more secondary, maybe a more exploratory analyses. Absolutely, you can do exploratory analyses within your systematic review and meta-analysis. That's absolutely fine. It can be really, really useful, but you need to define it and you need to let your reader know what's primary, what's secondary. So have a think about that. And finally, your study designs. Once you've done all the rest, this becomes kind of obvious, because if you've already decided, oh, I'm only going to look at studies that look against a randomized control group, obviously you're only going to include randomized control trials. Sometimes you might decide, all right, well, actually randomization isn't essential for my research questions. Well, like control trials, maybe I'll look at case cohort studies. Again, there's so many decisions to be made here. And I think that's this is a real challenge. Really put a lot of time and effort into figuring out your eligibility criteria, because they underpin everything that you're going to do. And there's a lot to consider. There really is a lot to consider. I suppose I think that deciding where to put your lines and deciding where to put these parameters, for me, very dependent on the question. I think something that is important is considering the stage of the research line and the data that's available to you. So if you are working in a topic that say is quite advanced, you're probably going to have studies available to start to really dig down deep into more specific areas. If you're working in a research line that's maybe at the earlier stages where there is less consensus on anything, maybe you're going to look at broader level questions and maybe just use it as an opportunity to highlight directions for future research. So really you need to consider where you're at, what's available to you, and what's the best way to answer your own particular question. Something that I get asked, people ask quite a lot, is like, can I include this study? And like, it's your study, you can do whatever the hell you want with it. I think the real question that people are asking is, should I include that study? And that's a very different and a way more nuanced question. And really, it depends on your topic. So I suppose the take home from there would be really devote good time to defining these eligibility criteria. So once you've done that though, you've decided what you're going to do, you've decided what studies, what's the criteria, what's the characteristics of the studies that you're going to include, you then need to go and find those studies. This for me is essentially the data collection process. So what you need to do is to develop a search strategy and decide on your strategy for selecting, for screening and selecting. Now, there's a lot of resources out there available to help you with this. I'm going to just very briefly talk through some factors to consider. Ideally, if we were doing this in detail, I could screen share, we could go through a few different databases and look at how to set it up, but we don't have time for that right now. However, I'm just going to give you the factors to consider, and then, to be honest, the best way to then learn is just go and have a play around. Not your formal searches, but pilot your searches, different key setups, and see what comes back. But some things that you want to keep in mind when you are developing this is, number one, you're going to need to look at the search terms that are required to source all the materials that are going to be relevant to your research question. So you've decided that this is the type of study that I want to let in, that I need to consider to answer my question. You now need to make sure that you have got a search strategy that will make sure that you actually can identify, can source that study. You really want to make sure that your review is based on all available information, because otherwise, what's the point? So really think carefully about how you're going to set this up. In terms of your free text terms, that's just where you're deciding what terms are most relevant to you. I think it can be really useful to have it read a lot around your topic area, but also have a chat with your collaborating team in terms of what are the best terms that you need to include here. Mesh headings, they're a way used by the National Library of Medicine, essentially how they index their terms. So it's good to use a combination between free text and mesh heading terms, and there's a lot of good resources available that can kind of teach you how to do that, and I'll provide some links to these resources at the end. Once you've put everything together, or once you've kind of decided what terms you're going to include, you need to think about putting them together, and basically use something called Boolean, I have no idea how to pronounce that, because I've only ever seen it written down, but Boolean operators to do this. So essentially, if you put the word "and" between your terms, the database is going to throw back articles that have both of those. If you put "or," it will, so say for example, you put physical activity or supplementation, it will give you everything that says supplementation, everything that has physical activity. Be careful there, that will get it huge. So where you'll use this is where there's basically different words that are going to give you similar information. So for example, maybe you're going to put exercise or physical activity or mechanical loading or training intervention, things that, different ways that people could feasibly describe the same thing, and you put them together in the "or." So then the engine will select the ones, all possible permutations. You can also use the phrase "not" to get rid of things that you don't want. Be a little bit careful about this one, because, so for example, I'm working on a project right now that's about the bone biomarker response to an acute bout of exercise. And I made a very difficult job for myself by deciding to just basically consider everything, and it's a big mess, and it's fascinating to work on, but it's huge. But when we were looking at the searches, I got an awful lot of hits around dentistry, because they use bone biomarkers a lot. And it would be quite useful to put in, actually I didn't think of it at the time, so I didn't, but it could be useful to maybe put in physical activity or exercise, etc., and bone biomarkers, not dentistry. Might help you to filter out a few, but just be a little bit careful, because sometimes within that "not," if that term is mentioned anywhere, it's going to get rid of it. So maybe you have an exercise intervention where they just state somewhere, but biomarkers are used in a variety of contexts, e.g. dentistry, and then they go on with my very relevant study. By putting "not," I've already gotten rid of that. So that's a little bit tricky. You can take a screenshot, phrase searching, truncation, wildcards, different things that you can consider to set up your search. Again, play around with this a little bit. Choose your filters. What date ranges are you going to search? What article types are you going to let in? You look at human versus animal studies. Different databases have different filters that you need to decide. And choose your information sources. There's a lot of different databases out there. Medline, Embase, Sportdiscus, blah, 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 blah. There's lots and lots available. So you need to choose the ones that are most suited to you. you could say, oh, use them all, but that's going to get pretty massive. In general, I think choosing 3 is good. Definitely do more than one, because they do search, their algorithms work in slightly different ways, and they'll search different sources. So have a combination. I think 3 is a reasonable number to go with, but obviously the more the better, you could also say. Also consider if you're going to do any secondary search strategies. So personally, I find that citation screening of included articles are really good. So what I typically do is I have my search strategy, I have all the databases, I have all my search terms, and I go through all that and I do my formal search strategy. And then I take the articles that I've decided are relevant for my review and I scan their reference lists, and yeah, I'll often pick up on another 1 or 2 there, particularly say older studies that maybe are not necessarily indexed. So that can be another useful way to look. There also, maybe there's somebody in your area who's essentially been working in this area their entire life, who maybe you want to have a look at, say, their study websites to see if there's anything you've missed. So you have options there to do that. And again, I'll link to some resources. I'll talk through this in more detail. I think something really important to consider here is you need to strike a balance between sensitivity and specificity. Like, of course, you want to be as inclusive and to optimize your chances of getting all the relevant information. That's obviously hugely important. However, this can explode very, very quickly. If you are putting all the terms in, covering all bases, you can very quickly get to something that's completely unmanageable. If your search strategy returns like 40,000 hits, by the time you make it all the way through those, there's going to be new research out there, which means you need to start again. So you have to be pragmatic as well. This is actually something I personally need to upskill on because it is tricky. All the databases are set up differently and there's a lot of nuances there. But I would say that we all work in universities that have librarians that are trained to do this. So let's just seek support. Like, now, it would be fairly unusual if your librarian happened to be a topic-specific expert as well and was going to be able to define all your search terms for you. Like, that would be fantastic, but it's maybe not entirely realistic. However, if you've done the work on putting together your search terms and pretty sure about what you want to include there, they can maybe help you then set up your databases and search. And I just always think sometimes we try to do everything on our own and we can't, and when there's people there that can help us out and that can be better at a particular aspect, go for it, ask for help wherever possible. Once you've set all of this up, you run your searches, and it's very important that you keep very clear records right the way throughout the process. Now, this is actually the checklist from the PRISMA guidelines, that they recommend. Actually, I just realized just before here, this is actually the PRISMA 2009 checklist. They've updated it a little bit, so have a look at that new 2020 version, which again I linked to towards the end. However, it's very important that you maintain a record right the way throughout of how many hits you get, where you're excluding, why you're excluding. It's easy to lose track, so have a system and practice your system before you do it for real, because it can be tricky, especially if you've got a larger search with a lot of hits. Now, luckily, there are some great softwares available that can help you manage this. So, for example, I really like Covidence, which is by the Cochrane organization, and essentially this is just a systematic review management software. So you will do your searches, you will download your files, generally in a format, I think it's .ris is the kind of file type that reads citations, and you upload them all there, and then they just very nicely sort them out to you in different phases. You're going to start out with a title and abstract screen, where you can tell very quickly that a lot of studies are not going to be relevant. You don't need to read them all in detail. You can get rid of an awful lot at the very beginning, and it's going to be very clear that some are not relevant. So you do that initial kind of sorting, and then you're going to come down to a full text review where you're going to upload your PDFs and actually get in and check the details of each one. It's highly recommended to do this in duplicate, independently and in duplicate, and this software can allow you to manage that. So you just send the link to your collaborator. You do it independently, and you can see each other's progress. You can see who's going quicker if you want to. I always get a bit competitive when I see my collaborators going ahead of me, but it's just a really nice way to manage things. And if you've got say complex at the end where I said yes and my collaborator said no, it stores all them. So it's just a really nice way to keep track of things, and I really do recommend using something like this. Confidence is actually a subscription service, so if you can't get it via your university, there are other options. For example, I've used one called Ryan, QCRI, which is a freely available app. I'm a little bit more accustomed to using Confidence and kind of I know the setup a little bit better, so that's the one I tend to go with. However, I have used Ryan and it's been great as well. It's free, so that's another possibility for organising your searches. So,
Eimear, can we take a few questions?
Yeah, sure.
Is that because there's a few about searches, and one I think you answered. They said, is it better to do it alone, with co-authors, and with a medical librarian? I think you touched on that.
I would say for sure, if you can get, I'd say get your co-authors to get together to figure out the search terms, etc. Medical expert, absolutely, if you're has a medical slant. And I really would recommend bring your strategy to a librarian, because all the databases are set up in a little bit different way. There's a lot of tips and tricks, and they're trained to do it. Well, I can't speak obviously for you guys, but I'm not. So I would definitely recommend get some support, because it's amazing sometimes when you're doing your pilots, what you think are relatively subtle changes to your search strategy. Sometimes you explode from a few hundred hits to like 10,000. You're like, whoa, what just happened? And there's a lot in there, so definitely get support if you can. And
there was a second question on using databases such as SportDiscus that have a subscription fee. Apparently there was a recent reviewer comment who questioned the use of a paid database in the review.
I'd be interested, I wonder what the comment was. SportDiscus, I generally always use it because I find that I'm generally picking up some studies that, some very exercise specific studies. For example, there's a few very exercise specific journals that are indexed there that don't always crop up in, say, Medline or Embase, or those more generalized ones. You generally get a lot fewer searches, but it can be quite useful in exercise science. From the point of view of the paid bit, I think my understanding was that they're all subscription. It's just that our universities pay for them, so that we have access. Now, I actually don't personally have access to SportDiscus, so I send my search strategies to a mate and get her to run it for me, and send me back the results. I wouldn't let paid or unpaid be a barrier. I just choose the most appropriate sources and go with it. And it's always handy to have a network of people where if your particular library or university doesn't, that maybe I'm not supposed to say that, copyright laws, but between your teams, somebody should have access. I thought that they were all paid, just that the libraries paid for them. So I personally would have no problem, and I think it can be appropriate for sports science specific studies.
All right, onward.
All right, cool. In general, is the audio, the video doing okay? Are we hearing me okay? Sometimes I get the way through, and then somebody comes in and like, oh, we haven't heard you for the last while. Like, okay. Right, so once you've kind of sorted through your search, if your eligibility criteria and if your question is clearly defined and your eligibility criteria is clearly defined, it should be very straightforward. It should be very much a black and white, they're in or they're out. If you find yourself searching, thinking, oh, I'm not sure whether I should include this or not, you probably need to go back to revisit your eligibility criteria, because you probably haven't been specific enough. And again, that's why it's so important to pilot and test all of these strategies before you do it for real, so that you can iron out all of these wrinkles along the way. But once you get to the end of this, you're going to have a body of research. You're going to have a bunch of studies, and what do you do with them next? So essentially, you are going to now enter into the phase of planning your data extraction and coding strategy. Actually, those softwares that I pointed out do have extraction features, but I'm kind of old school and I do it with Excel because I don't know, I just like it. But absolutely consider all options, figure out the way that's best for you. So the way I do it is essentially I start out with a nice large Excel sheet that has all of the parameters that I want to take out. So just for example, this is one that I'm working on right now. Again, as I mentioned, bone biomarkers in response to acute exercise. So I start out with the study details that I need to extract, everything about the participants that I want to pull out, the exercise test details, the testing conditions, which is quite important for my one, and the bone biomarker measures themselves. So obviously this is going to be hugely dependent on your own. However, this is just an idea of how you might set up your spreadsheet. Typically I have two versions. So I have this one where I'm extracting initially, and there's quite a lot of text in there. I'm taking full sentences, I'm taking all of the information. And then I have my analysis file, which is where I kind of pull out what's essential for the statistical analysis, and I do my coding. So you kind of have your raw master sheet that has everything, and it tends to be pretty big. And then you have your coded or adapted, or say, for example, often the studies will say report standard error of the mean instead of standard deviation, and maybe I need to convert that, or maybe the authors haven't reported something that I need and I need to get in touch. So I have this big master sheet, and then I have my analysis file, my kind of cleaned analysis file. One thing that I think is so essential is write down everything. It can be a notebook beside you, it can be a Word document. I have comment boxes at the end of when I'm doing my studies. While you're reading, things are going to come to you. You're going to get new ideas. Some authors are going to say something in a way that just surprises you, and you need to go away and think about it. There's so much is going to come to you. You're going to think that you'll remember it because it's so important. You won't. After a long day of extracting studies, you'll struggle to remember your own name, never mind about what you read 6 hours ago in article 3, page 4, line 17. You note everything, even if it seems a bit irrelevant or seems a bit obvious at the time. Keep notes, keep recording. You're dealing with a lot of information here, so just try to be as organized as possible. Again, ideally, you do your extraction in duplicate and then come together to verify your results. It seems like it should be so easy, but like we're just taking the data. Why would I need to do this in duplicate? Again, it can be tedious, it can be time consuming, it's very easy to make mistakes. So I think it's definitely advisable to do all of this in duplicate and to then verify. Is there anything else I want to say? Oh, small little tip that I find quite useful. When you're extracting, I always highlight, when I read the article initially, I highlight where I'm getting the information from, and it just makes it that much quicker if I need to go back and check something, that I can then get straight to it. So alongside your data extraction sheet, develop a code book. So I just use a table in Word, and just describe what you have in each section and how you're organizing each section. So you need to decide here whether you're going to take the data as it is, as continuous variables. So for example, let's say I'm looking at a bone formation marker, P1MP, pre and post an exercise bout. I'm going to pull out the actual means and standard deviations that are reported. However, I also have a lot of other factors that I need to consider. For example, I'm looking at whether these bone biomarkers, what process they represent, so formation or resorption. So I'm coding that. And you need to think about the way you're going to set this up, and I'm going to talk a little bit about the statistics now in a moment. So that obviously will feed into it. And again, I think all of these steps that I'm talking about, they're all sequential, but they all feed on each other, and that's why you really need to develop and pilot all of them before you get started, because when you start thinking, for example, about your data synthesis, that's really going to impact how you set up your coding. How you set up your coding is going to completely depend on your research question and say what potential modifiers or moderators you're looking for. So everything feeds into each other. So really do plan out every stage before you get started. You're going to be coding in theory. Sounds very interesting. Sounds very straightforward. However, a lot of the authors are not going to conveniently set up their papers in exactly the way that you need it to. So you need to consider the strategy that you're going to use to deal with any missing information that arises. First and foremost, email the author, try and get it. And second, consider how necessary it is. If you're missing data that's essential for your study, well, obviously you're going to need to exclude that. However, if they're missing maybe some detail that you might think might be interesting for a secondary exploratory analysis, but you have all the information for your primary, well, sure, go ahead. Would be my approach. So again, think about what you need. Point of view of data synthesis, you've now got a massive spreadsheet all set up, all ready to go. You need to now combine that into some kind of common effect. I will do a disclaimer here, I am not a statistician, so having listened to fantastic presentations by statisticians like Aaron Caldwell and Kirsten Sainini in the STORK summer series, I wouldn't embarrass myself by attempting to get into the details of statistical analysis, and for sure here we don't have time. I'm aware that I'm already probably running a bit behind schedule. Once I start talking on this, I find it hard to stop. Yeah, your data synthesis, it's huge. It's what everyone is going to take away from your study. So you really do need to think about what you're doing here. So have a plan in place for that. Like I say, I think perhaps on another session, if there's interest, having a session devoted specifically to statistical meta-analysis could be really useful. But for now, I'm just going to give some kind of general guidelines. So basically, when we talk about statistical meta-analysis, we're referring to the statistical combination of results from multiple studies. So what you're often going to get is one single combined effect size with confidence intervals. And I'm sure a lot of you have seen this. It's called a forest plot. It's essentially where you take the effect size and confidence intervals from individual studies and you combine them into a single one. And the length of your confidence intervals are going to be very much determined by the size of your sample. So when you combine them, you're going to start shrinking them, which can give you a better idea of what's actually going on. So as we can see here, we've got 4 studies. Now, if you took them in isolation, studies 1 and 3 will be considered non-significant because they're crossing the 0. However, when you consider everything together, it really does seem like something is going on here. So that's basically what we're trying to do with a statistical meta-analysis, is to bring everything together to see if we can identify patterns that maybe we couldn't see in the individual studies. Very simple meta-analyses are actually pretty simple to do. There are things you can just plug in numbers and get a combined effect size. However, be very careful here because most meta-analyses are not simple. And in the fields that we work in sport and exercise science, kinesiology, we know that there's moderators for pretty much everything that we do. So let's just say, for example, that vitamin D study the hypothetical vitamin D study I talked about earlier. There's a huge difference in bringing somebody who's deficient in vitamin D and supplementing them until they're sufficient, and taking somebody who's already sufficient in vitamin D and making them a bit more sufficient. Now, the deficient to sufficient person might have quite a decent response. The sufficient to a bit more sufficient person probably won't see anything. Now, if you lump all of those in together, what you're probably going to end up seeing at the end is an effect that crosses 0 and shows that there's really nothing going on, but you might have missed the point. And so you need to be very careful about your eligibility criteria to make sure that you're considering those factors, or you need to do something more complex that allows you to parse out these factors. And there you're getting into the regions of using multi-level models, meta-regression, maybe network analyses, more complex analyses. Now, I am extremely fortunate in that I have a close collaborator called Paul Swinton from Scotland, he's a statistician, but he did his initial work in strength and conditioning. So he kind of has both the exercise science and he's also a chartered statistician. That's his specialty now. And actually, I've never done a meta-analysis without him, and I have no desire to ever do a meta-analysis without him. So I am very fortunate in that I have advice there. And I think the one thing that I've taken from working with somebody that has such a strong knowledge of the area is just how tricky it can get. And so I think in this, if it's feasible, and depending on your research question, getting statistical support ranges from certainly advisable to absolutely essential, depending on the complexity of what you want to do. One note I'd like to make there, I think collaboration with statisticians is hugely important. But you can't just give them your data extraction sheet and say, here's numbers, tell me something. It has to be a conversation. You need to go to them with your question. They're not going to know the ins and outs of your question. They're not going to know all of the boundary conditions that you put in it, the parameters that you decided, and the different potential moderators. So it needs to be a conversation. You need to let them know what your question is and what you're trying to get to the bottom of, and then allow them to advise you on how to get there. So yeah, by this stage, we have now combined our data into a nice summary. We've reached a conclusion. Oh, sorry, one thing just to note on that, it's perfectly possible to do a systematic review without a meta-analysis. Sometimes meta-analysis isn't the most appropriate. Sometimes you'll synthesize your data in other ways, so keep that in mind. But yeah, once you've gotten to this stage, the last thing that I think is very important for you to consider is how you're going to ascertain your level of confidence or certainty in those outcomes that you've just come to. It would be nice to say all published research is perfect, and once we bring it all together, we've now got an answer, full stop, we're done, but that's just simply not the case. So it's very important that you consider how confident you are in the outcomes that you're coming to, so that you can write it up in a way that is informative to your readers. And there's a very nice system called the GRADE system, Grading of Recommendations, Assessment, Development and Evaluation, which provides a framework that allows you to rate the quality of outcomes, of those whole outcomes of that end product, and not just of specific studies. So when you're doing this, when you're looking at this, you've got a whole range of potential downgrading and upgrading factors that you need to consider. I'm aware that I'm starting to run low on time, so I'll go through this very quickly. At the level of the individual study, you're going to look at risk of bias and whether those individual studies that you include in your analyses are likely to be affected by bias or not. And there's a lot of different tools available. And again, I'll provide some links to do them. Pick the tool that's best for your own research question. Like I mentioned, we're measuring surrogates rather than actual parameters. So it's important to consider how direct the information that you have is to your research question. So for example, I recently worked on a paper in looking at the effective menstrual cycle phase on exercise performance. And we've got a lot of studies, but menstrual phases are highly variable between different women, and possibly within. And so it was very important that the studies included confirmed what they were doing. So there's a variety of different measures to confirm, and we kind of rank them and we downgraded our confidence in ones that didn't use what we consider to be the optimal methods. Inconsistency and imprecision are basically going to be based on the results of your meta-analyses. If you've got wildly inconsistent results, probably your combined estimate is going to say that there's nothing going on. But if you can clearly see that some studies say there's a very strongly positive effect and others a very negative effect, you're missing something there. So you're not going to be overly confident in that result. So you can downgrade your confidence. Imprecision is based on essentially the number of outcomes that you have. If you only have 2 studies that report on one particular thing, you're not going to be hugely confident in that. So you might downgrade your overall level of confidence. And you also need to consider publication bias, which I think most of us are aware is probably quite a big problem in our area. Our effects tend to seem much bigger than they actually are, mainly because we only report the positive ones. So that's something that needs to be considered. I'm not going to continue talking about this now because I think we'll run out of time. But just as a tip for learning more about this, the Cochrane organisation have a series of slide-casts that talk through each of these factors and explain how they can be applied and give some examples. So that's a very useful resource. So there we are. Once you have decided if it's right for you, defined your question, defined your eligibility criteria, piloted your search and selection strategy, piloted your data extraction sheet and code book, established your data synthesis strategy, and decided how you will ascertain your level of confidence, you're done. And you are now ready to start. This is the planning stage. So obviously, look, there's a lot there to consider. And I would really recommend once you get to the stage where you've put so much work into developing this protocol, register it and/or publish it. Jennifer Sherwood already gave a really fascinating talk in the STORK summer series on pre-registration and how important it is. So I'm not going to rehash that, but I think it's hugely important. And for me, pre-registration is often a good idea. Is more often than not a good idea. And we're aware that things like outcome switching, harking, are problems in scientific research, and these can help to prevent that, and also encourages you to put the time and effort into developing your plan before you put it into practice. I think this is extra important with systematic reviews and meta-analyses because you're working with secondary data. So like there's nothing to stop you going back and completely changing everything you plan to do after you see your results. That's not advice. Don't do that. But I think it's really important that we register our plan. One thing I'd like to highlight, in the new Prisma 2020 checklist, there's a section around registration of your protocol and whether you did it. And they included a section saying, describe and explain any amendments to information provided at the registration or in the protocol. And I think that's really important, because no matter how much time you put in planning, things will crop up when you start to put it into practice that might make you want to adapt your plan. And I think we have to be, in order for open science to work, we have to be willing to adapt depending on how things go. Like, none of it's perfect. There's going to be things that are going to rise. There's going to be things that you didn't think of, and that's okay. Just be transparent about it. Particularly, new research is going to come out that might change your perspective. So you have to be okay with that, and I think it's important to have that. So don't worry if you publish your protocol and then think, oh no, I missed something. That's okay, you're human. Go easy on yourself. But I really do recommend that you do put that time-stamped version of your protocol once you're ready before you actually run it. Guys, I'm not sure what's the easiest way. I know I've talked about a lot of different things here, and most of it in a relatively superficial kind of overview kind of way. All of these resources here will basically go into a lot more detail on all of the specific parameters that I've talked about today. So like, my intention today was just to kind of give an overview of the things that you should consider that may or may not be relevant for your specific question. But as you start to get into the nitty-gritty of actually running your analysis, you're going to want to explore these in a little bit more detail. So I would recommend visiting some of these sites, the Prisma site, the Cochrane collaboration, and those new Prisma 2020 guidelines and statements, really important.
Perfect. So we're coming to the top of the hour, but there's quite a few questions. So I'm going to ask you if you feel comfortable sharing your slides with me, and I'm going to share the chat questions with you and get kind of a document and email answers to questions and the slides with all the links to everybody on the call. Will that work? Yep. And this will be recorded and it'll be on our YouTube channel. So I'll send all that information out to everybody that registered today as well. And then we'll put links out on Twitter as well. But so we're just gonna say thank you, because we're really, I want to be mindful of everybody's time and of your time. I really appreciate, this is super exciting, and I think you did a great balance of, it's completely doable, here are the steps, but you know, this is a lot of work and take it seriously. So, because I think you're right, a lot of people are like, global pandemic.
Do it, it's great, I enjoy it, but don't do it lightly.
Okay, all right. So thanks to everybody on the call again. I'll send out an email with the slides and information on STORK. Please consider becoming a member if you pop in on our series. We have the next fall series number 2, November 18th, and it's looking at specification curve analysis. So I will be there because I have no idea what that is. And I think it's a great idea for even a step 2 to this topic, if anybody's interested in presenting that or presenting anything. We're going to have a winter series, probably moving into the spring, so please email me ideas. All right, Eimear, thank you so much. This was great way to start.
Sorry if I rambled off. I knew I'd do it. I knew I'd spend too much time at the beginning and not the end, but it was just, I was just wrapping up with the kind of bottom line thing. So there's, we're pretty much done, but apologies I didn't get time to take the questions, but I'll be more than happy to.
Yeah, and I think having the questions written down anyways is going to be helpful for everyone. All right, so I'm going to stop the recording now.